Aloha, this is ITS128. It's Thursday, November 5th, the day 3 of election 2020. And let me share my screen here. So what I did earlier today is I made a bunch of little videos on some of the challenge activities that people have asked me about. And so and if you would like me to do particular challenge activities that I do not cover in class, and sometimes they might take a while. Also, I take a little bit different approach on these. I actually start without looking at the problem, and I do that so if I enter something that's wrong, or I'm something stuck in my head and I can't remember it, then I think it through out loud, and sometimes I might have to go on the web and figure something out. But anyway, so the idea is that it helps you sort of with the thinking process, and they're very short. I made separate videos, so they're just like 6 minutes, 6 minutes, 7 minutes, and 15 minutes. I don't know why that one's so long, but anyway, I may make these videos unlisted because they sort of directly answer problems that are in the textbook. And I got in trouble few years ago when I would post up the solution, a video to the solution. I think that was like an ICS 101 when I was teaching ICS 101. I would post up solutions to the grader projects, and Pearson actually contacted me and asked me to make them unlisted. That I can make them for my students, but don't make them publicly available because other instructors who also use the same textbook, the Pearson, the My IT Lab, were complaining. So anyway, so those are there. And so today I'd like to start with the function, the labs at the end. And so I'm going to just start going through the labs. I'll go through them, and and I'm not going to get through all of them. And today's the last day of this chapter. Let's see, today is November 5th, and next Tuesday we start strings. I may go into the next day because I noticed we spend 2 days on, but there's Thanksgiving. So I think there might be another holiday. Is there another holiday next week? I think there is. Let's see, let me pull up my chat here just in case anybody wants to say anything to me. So anyway, so let's start with these zyLabs here. Let's start with this one. And I think I'll do the same thing I did when I was making the videos for my for those challenge activities. I may just start by looking at this without my notes and sort of work through it. Okay, the first one, miles to track laps. Okay, one lap around a standard high school running track is 1/4 mile. Write functions miles to laps that takes the number of miles as an argument and returns the number of laps that you, I guess, would need to run. Complete the program to output the number of laps. Okay, so we got this program here. I'm going to bring up my notes. If you're looking, someone just asked me a question. I haven't updated the scores for a while yet. So if the scores in La Lima don't look right, it's okay, if the scores in Alima don't look right and you've done them, then it is because I haven't copied over the scores, because uh, and then after I've copied over the scores, if you find an error, then let me know, because if I copied yours over wrong, I probably copied others over wrong too. So it takes me a while to sort of, it's a process that I developed, and I'm behind actually in all my classes. I use zyBooks in all my classes, and so anyway, sorry about that. The score that you have in zyBooks is the score that and if you got all the points in zyBooks, then you will have gotten all the scores in Lalima. There would be no reason for me to give you a score other than that. All right, so let me just, I think I might have some notes here on this. It's ITS128, fall 2020, and we are in chapter 6. Oh no, I don't. I haven't done any of these yet. All right, so let's start this from scratch. Just a minute. I'm gonna I do want to take a look at this for a second. Let me just close this down here, and I'm gonna ugh. I want to start to record these things. So let me open this up, and let me open this up. And I'm going to save as, these are labs. And the first one is this. And let me put this back over here. Okay, so in this lab we have to, oh shoot, so I didn't mean to show you that. Oh well. when you run this again, you can catch that and stop it and see the solution, I guess, if you want to. But it'd be better if you watched what I do right now. So I'm going to start by copying, not this. I was in a meeting just before this meeting, and I didn't get a chance to clear out everything before I. Okay, so I'm going to start with this, and that is simply, and the question is this. I'm going to do this. I'll tell you what. Is this. It's this problem. And all we need to do is all my screens are different sizes, so it's smaller. All right, one lab. Okay, so the input is this, the output is this. That makes sense. You times 4. Okay, so we need to make a function. Oh boy, where is it? Oh, here it is. Type your code in that calls the function. Well, it's something like we have to output this. And so I'm going to put that there. And so that's going to be at the end of my thing. And I have to make a function that converts miles to laps. So I'm going to make a function. Put this here. Up here. def miles to laps, colon, and what comes in is miles, M, maybe miles. And we want to return laps. So something like laps equals miles times 4, yeah? That makes sense. And then return laps. And then here we need to just make a function that first reads in miles, and I'm just going to call it the same, input enter number of miles. And so we need to, and we want that to be, we want them to be able to enter. Am I recording? Yes, I'm recording. All right. Yeah. And I got my mute off. You don't know how many times I started making the video this morning and I had my mute on. It's like I had to start all over again twice. One of them I got almost all the way through. And I looked up and it says you're muted. So I read in this miles, and and it can be a floating point number, so you can have a decimal point. So I might as well just convert it right there. And then then I want to compute the laps. Num laps equals miles to laps. I don't put this word function here. Miles to laps, miles. So I read it in, I pass it in as the argument to my function here, miles to laps. Comes in here, this is what I read in, multiplied by 4, because it's 4 laps to a mile, computed laps, and I return laps. And so this takes on the value of the returned value of for laps, and that gets assigned there. And then I guess I print it out, this thing. And I'm gonna be stupid here, and I'm just gonna put that there. I would put laps, but I'm just trying to make a point here. And the point is that you can name your variables anything. It's just a name, and it's how it operates or what it does for you that matters. All right, so I've read this, I've entered it in. Okay, so I'm just going to see if this works. I'm going to save this, and I'm going to run it. Clear. I'm going to run it. The name of this program is test.py. Better make sure it's saved. And I'm going to run this. The first thing it asks me is number of miles. And if my input is 1.5, it says 6.0. Yeah, if the input is 2.2, then the output is 8.8. Yeah, it looks right. Okay, so so that's good. I'll let you work on that. There's the answer. Allow me to leave. I wanted to leave. All right, let's just do this one. This time I'm not going to use any notes. All right, lab max magnitude. Okay, so I have a, all right, write a function called max magnitude. So I got to define this thing. I'm going to copy this. No, here's what I'm going to do. Open this up, clear it. Oops, yeah. Just clear it. I'm I'm going to copy this in there. Copy. And my code's going to go there. My function's going to go here. And what is that function? It's going to be this thing. Copy. Paste. Colon. Now, what is this supposed to do? Write a program with two integer input parameters, write a function with two integer input parameters, which returns the largest magnitude value. Whatever, okay. Oh yeah, magnitude. Okay, magnitude, it means you take the absolute value first. That must be why we have to import math. Because comparing -5 and 2, the largest magnitude would be the -5, he thinks. It is. Okay, use the function in a program which takes two integer inputs and outputs the largest magnitude value. Alrighty, so I'm gonna do this. Type my code here. I'm gonna go, I gotta read it in. V1 equals integer, int, input, enter first integer. V2, int, input, enter second integer. Am I supposed to print something? Print max magnitude V1 comma V2. All right, so that's going to print it. And how do I figure out what it is? Well, it's probably return maximum of absolute value. Is that a function? Yeah, I bet it is. Okay, absolute value of what? This. No, that's not right. It's because I actually have to print out the value, I can't print out the absolute value of it. I'm not going to use the max function. I'm going to write my own function. If ABS user val1 is greater than ABS user val2, if this is true, then print user val1. Else print user val2. And I got to make sure that these are tabbed properly. I'm just going to go tab, 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 double click, tab, double click, tab, tab, double click, tab, double click, tab, double click, tab, There's probably some way I can adjust my editor, my edit Node++ or whatever. Okay, so now let me run this. Let me save it and run it. Oh, else. There we go. All right. So run it. Oh, I got to put a colon there, I bet. Save it. Run it. First integer is 5. Second integer is 7, and it prints out 7. Why is it printing none? Oh, what am I doing? Oh, I got to return this. I don't got to print it, I return it. Returned user val 1. And this one is return user val 2. All right, that's better. Now let's run it. 5, 7, yes. And then what's next? Oh, let's run it again. -8, -2. Yes, -8 is higher magnitude. How about yeah, well, -8. Let's run it. Ooh, I wonder what's if I say -8, 8. It just says 8. It's because I did the last one. Because this isn't true. Well, anyway, I'm not sure what the right answer is. So why don't you run it? And if this isn't the right answer and you can't figure it out, then you can let me know, and I'll look at it and figure it out. In fact, I could look right now.
Excuse me.
Yes.
Sorry, I know time is not good, but can you explain it one more time? I'm a little confused.
Explain this problem one more time.
Yeah, the answer.
Sure.
Thank you.
All right. So let's see. So you understand about how you got to read in. You're reading in 2 numbers, and then you create this function here called max magnitude, and you pass the 2 numbers in there, and then it comes in here, and then it figures out which one is the right answer. Okay. So so let me just break this down into more simple stuff. I'm going to say, okay, I'm going to say V1 equals, no, I'm going to say this, AV1 equals ABS for absolute value of user val 1, okay? And then I'm going to say print first user val 1 equals I'm going to say this, absolute value of ABS of user val 1 equals AV1. Okay, so I'm just going to do this so we can see what these absolute value things look like. Okay, so now we're going to see this 2, 2, 2. Okay, and then let's do this first. So first I'm just going to run this so we can see what it looks like. I got to put a comma someplace. Oh, yeah, comma. Okay, so let's run this again. Did I not save it? Didn't save it. Okay, so I'm gonna do like 7 and minus 8. Okay. So here it says if the absolute value of 7 equals 7, the absolute value of minus 8 is 8, is just plain old 8. So what absolute value does is if something is negative, it strips off the negative. So when we mean magnitude, magnitude usually means it's kind of like without direction. It's like if you have like a number line or something, you have a number line here, and let's say this is +2, and this is 1, 2, 3, and this is -3. See, and this is 0. Then if we ask ourselves which one is larger, which number is larger? Well, clearly it's 2, because 2 is over here and 3 is way down, and -3 is way down here. +2 is larger than -3. But if we want magnitude, that means it's just the distance, this distance versus this distance. Okay, so it doesn't matter if it's that way or that way or that way. It's just the distance. It's the magnitude. It's how strong it is. How strong it is in either direction. Okay, so when we're asking for the magnitude of something, the maximum magnitude, we're just asking for which one is farther away from 0. Really, which one is farther away from 0? So to do that, we want to convert it to something where all we're talking about is distance from 0. And so that's why we want to make the signs be the same thing. We aren't distinguishing between negative and negative numbers and positive numbers. Positive numbers are always bigger than negative numbers. We want distance from 0. So to get distance from 0, we take the absolute value, and the absolute value is kind of what it sounds like. It's the absolute distance, regardless of whether it's negative or positive. And so really, all the absolute value function does is it looks at it. If it's positive, it leaves it alone. If it's negative, it makes it positive. It just strips off the minus sign. And so in this little example here, I'm going to take whatever is input, and I'm going to make it absolute value. And so that just strips off the negative sign if there is one. Same with the second one. And then I'm just going to say if AV1 is, so now we're just they're both positive. And so now we just want to see which positive number is bigger. So if AV1 is bigger than AV2, then we know that that's user val 1, that this one, which corresponds to this. So if this is greater than this, then this is the one that we return. It's either going to be one or the other. This doesn't consider the case if they're both, if one's -8 and one's +8. If one's -8 and one's +8, it's going to take the first one. No, it's going to take the second one because the first one didn't pass. So let's do that. So this is if the first one is higher magnitude than the second one, then the first one is the answer. Otherwise, this one's the answer. And so we really could do something like, okay, so let's run this. Okay, let's run this again. And if I -7, 3, we see that the absolute value of -7 is 7. The absolute value of +3 is 3. So the answer, now the answer is it this one or this one? So the answer has got to be either this one or this one. So that's why we don't say the answer is +7. We say the answer is -7 because it was the -7 that was actually entered. Now the problem with this particular way we've written it is if we do, 7 and -7, 7 and -7, it's gonna take the second one because the first one would have to be greater than the second one. We could do this, greater than or equal to, then it would do the first one first. So then if we do the same thing, 7 minus 7, we're going to get the first one. Because when it got to here, it's going to be, is 7 greater than or equal to 7? Yes, it is. So just print it out. Is that more clear?
Yes, thank you.
Okay, great. Perfect. Good answer. Good question. All right, so let's do the next one. Oh, okay. So when you actually put your answer in here, how do I unshow this? So when you actually put your answer in here, you want to make sure that, you're going to want to get rid of it. Well, you can leave this here, but you want to get rid of this. You can get rid of it by putting a comment there. Get rid of this, put a comment there. That's fine. So this will probably work. I'm pretty sure this will work. The solution actually has math dot floating point absolute value. Oh, well, is it? Anyway, but you may need to use Python math absolute value is ABS. Oh, it doesn't ABS. Python math class. The solution actually uses this one, math.fabs. Yeah, let's see. Math. See, that's why we did this. I think we still have to do that. I'm going to try taking this out and see if it'll work. This could still work. Save. Uh, 7 minus 9 still works. So I don't even need this import math. But did I save it? But I can't do this. Let me try this. Math.fabs. See, this is not going to work. Seven minus 8 didn't work because it didn't know what this was. But if I do, well, anyway, so, all right, what's next? Oop, damn it. Showed you the answer again. Oh, well. What's next? Stop showing you the answer. Okay, driving costs. Driving is expensive. Write a program with the car's miles per gallon and gas dollars per gallon as input, and output the gas cost for 10, 50, and 400. Okay, and print it out this way. So if your input is miles per gallon and cost dollars per gallon. All right, so we want to write a function. I'm going to copy this. And the function is going to be this. Seems like I've done this problem already. Def that. Oh, def's already there. So we read that in, and let's see what the math looks like. Oh, okay. So we're going to input. I'm just going to put this in here. It's going to be in float. It all floats. Yeah, they're all floats. Miles equals float input. I hate it when it does that. Enter miles. And then price equals float input enter price per gallon. I'm just going to throw that in there so I know what I'm doing. Enter price per gallon. Yeah, just that's fine. I know what I mean. And miles. Oh, miles per gallon. Forgot the miles per gallon. Enter. I'm going to call that MPG. That'll be my abbreviation. MPG, miles per gallon, equals float miles per gallon. What? Oh no! Wait a minute. Do I return? I don't get what's going on here. Hold on, I might not understand what we're supposed to do here. What time is it? 3:55. If the input is this, is it like a default or something? Miles per gallon and dollars per gallon. And output that. Your program must define and call the following driving cost function. Driving cost function, which inputs driven miles and miles per gallon and dollars per gallon. Oh, I see. The dollars per gallon is, no. Miles is what changes. The miles is something that the program does. Okay, so the miles is something the program enters, and then I just have to input I ask the user miles per gallon and dollars per gallon. Okay, so miles per gallon. So I enter miles per gallon, and I enter dollars per gallon, and then I output float input enter miles. Why is it? I hate it when it doesn't. Per gallon. Enter price per gallon. And then what I want to do is I want to do print. Well, I'm just doing real basic. What is it? 50 miles. What am I supposed to do it in? 10, 50, and 400. I'm going to say I'm going to output the gas cost. Gas for gas cost for 10 miles equals driving cost for 10, I'm driving 10 miles and whatever the MPG is and whatever the price is. And then gas cost for 50 miles is going to equal driving cost for 50 miles. 50 miles, whatever miles per gallon, whatever dollars per gallon. MPG price, and price is really dollars per gallon. It's like you pay. I don't know how much gas is. I have an electric car, but it's like what, $4 a gallon, $3.50 a gallon or something. Gas cost for 400 miles, and of course I'm really breaking it down here. Maybe you wouldn't have all these extra variables, but no reason why you can't have all these variables. 400, and whatever the miles per gallon is, and whatever the price is at the time. And then what we want to do is print, I guess, gas cost for that one, and gas cost that one, and gas cost that one. Is that all we need to do? Okay, then let's figure out this function here. And we want to return a cost. Do they give us anything here? Oh, they want us to print it out this way? Oh. They want us to print it out this way. So let's do this. Copy this, and I'm going to do print that there, and I'm going to do this, and I'm going to put this here, and I'm going to do this end equals a space, and I'm going to put 50 here, and I'll put 400 here, and I think I'll just get rid of this thing here. And I don't need this anymore. All right, so I'm trying to break this down make it real simple. First, I read in the two numbers, and then I calculate these values using our function, which we haven't written yet, and I print it out this way. So basically, we're printing out a cost, right? We're printing out a cost, the cost of the trip in gas. The gas cost for the trip. So we have something that looks like okay, we want cost. We want driving cost per cost for 400 miles. 400. Let's do 10 miles. 10 miles times cost per mile. So I want dollars per mile. I want dollars per mile and I have miles per gallon, and I have dollars per gallon. I got those two numbers. And I want dollars per mile. I want dollars on the top, and I want miles on the bottom. So this isn't, if I just multiply this by this, that's not going to do it. I want to figure out how I can cancel out gallons. So what happens if I do dollars? So I want dollars per gallon times gallon per mile. Dollars per gallon times gallons per mile cancels these two things, and we end up with dollars per mile. That's what we want. Well, how do we make that equation? Well, we just take this is the right way. We got to make this one go upside down. So we actually want this to be, we want to flip this around, and so that's just taking the inverse of it, which is actually dollars per gallon divided by, we're divided by this, miles per gallon. Okay, that will equal, this will equal dollars per mile. Why? Because we can multiply this by gallons, and we can multiply the top and the bottom by gallons. Let's see, I'm trying to explain algebra to you also. Okay, gallons over gallons is 1, and you can multiply anything by 1, yeah? Because if it's the same on the top as on the bottom, it's just equal 1, and you can multiply anything by 1. And so here we're multiplying this by 1, and this cancels that, and that cancels that, turns out. The other way you can remember it is that this won't work because there's nothing to cancel. You got to put the two together, so you end up canceling the one that you don't want anymore. If you put the two together, start by putting the one that you want on top. You have that, you start with that, and then you take the other one, and you're either going to multiply just like it is, or take the reverse of it. And taking the upside down is like the same as dividing. Does that make sense? Somebody's about to say something. All right, so knowing that, we want to divide by, it's actually then, let me just erase all this thing. Oh, let me just erase it. So, so we have as input miles per gallon, and we've got dollars per gallon, and we want dollars per mile, and then we're going to multiply that by the number of miles, and so that gives us the cost per miles. And so to get, if you have these two things, and you want this, you want to cancel. It looks like it's gallons you want to get rid of, and you want the dollars to be on top. And so to cancel gallons, if you take something that's got gallons on the bottom, and you divide that by something else that has gallons on the bottom, then you can cancel out the gallons. So it's dollars per gallon divided by miles per gallon. Cancel out the gallons and you get dollars per mile. And then you multiply that by the number of miles. Let's say it's 10 miles. That's 10 miles multiplied by 10 miles. And you got miles on the top, miles on the bottom. Cancel those out, and you end up with 10 times what the dollar number was. So so knowing that, it's going to be miles driven miles. No, let's first figure out dollars per mile equals dollars per gallon, dollars on top, divided by miles per gallon. So the 2 gallons are on the bottom for both of them, and what you end up with just is dollars per mile, dollars over miles, and once we have dollars per mile, then we just multiply that by miles, and we end up with dollars. So driven miles. Let me say driven miles. Wait a minute. No. Dollars equals dollars per mile times miles times that. And that's what dollars is equal to. And we're going to return dollars. And so the first time we call this function, we're going to multiply that, driven miles is 10. Next time driven miles is 50, and the last time driven miles is 400. So I'm going to run this and see what this looks like. And I'm going to use these numbers: 20 miles per gallon and $3.15 whatever 99 per gas, very cheap gas. So enter miles per gallon is 20 miles per gallon. And the miles price per gallon is $3.1599 dollars per gallon, and we end up with 158, 790, and 663.20, all in one line. So anyway, so that's the math, that's the function, and it looks like I'm printing it out wrong, so I guess I don't want to have this there. And so you want to take these away, and also I put this in there, these in there, so I know what I'm doing, so I know what it's asking for, and I guess you wouldn't put those in there either. So anyway, so you should be able to do that one. All right, what's next? Step counter. A pedometer treats walking 2,000 steps as walking 1 mile. Write a program where you input the number of steps and it outputs the number of miles. Okay, so 2,000 equals 1 mile. So it's 2,000 steps per mile. And what are we supposed to do? We're supposed to make a function called that. All right, let's just get rid of all this. And I get rid of, okay, so we're supposed to make this function steps per mile, steps to miles. Steps to miles. And all right, so we have we enter we know that it's 2,000 steps per mile. 2,000 steps per 1 mile. Okay, that's what this says, 1 mile. Or we can just say 2,000 steps per mile. Another way we can look at this, say it is just 2,000 steps per mile. 2,000 steps per 1 mile. And we want to output, we want to input steps and output miles. So we have 2,000 steps per mile, and given steps, we want to calculate miles. So let's say steps is 5345. So given 2,000 steps per mile, I mean, we have 2,000 steps per mile, given 5345 steps, how many miles? Well, here we have miles on the bottom, and we have just steps. We have 5345 steps, and we've got this miles, and we want miles on top. So tell you what, let's just convert this to miles per step. Miles per step would be 1 over 2,000 miles per step. Okay, so this is like the inverse of this. But it's the same thing. It's 1 mile per 2,000 steps, or 2,000 steps per 1 mile. Same thing. So let's use this thing in this form, and so then we want to we get it. We just multiply by 5, 3, 4, 5. Make it easier for us to read that. Times 5, 3, 4, 5 steps, and we cancel this out and with that out, and we end up with miles. Miles is all that's left. So we calculate 1 over 2,000 times 5, 3, 4, 5. So basically, it's steps divided by 2,000 miles per step. Yeah, so that's what this is. This number of steps, 5, 3, 4, 5. I can't write very well. 5, 3, 4, 5 steps divided by 2,000 miles. That's what this is. 5, 3, 4, 5 times 1 over 2,000 miles. That's whatever. So that's how that would be. So it's simply, we have steps, and we want miles. Miles equals user steps divided by 2,000 steps per mile. Comment here is a number of steps divided by 2,000 steps per mile. Kind of like that. And this is those. So anyway, so this is the answer, and we want to return return miles. And so we want our code is going to look like enter input. It's integer value. So steps equals int input enter number of steps. And then print. I'll just calculate it out. Miles equals steps to miles, whatever was read in, steps. And then we can print miles this way. Copy, paste, and we want to put miles in here. This thing. All right. Of course, these two need to be the same up here, and these two need to be the same here, but this thing can be different as long as, it doesn't matter. So let's run this and see what this looks like. Enter number of steps, 53, 45, 2.67. Oh my gosh. So you need to, take out some stuff and get that to work. All right, let's keep moving here. A jiffy. A jiffy is a scientific name for 1/1000th of a second. Given the input the number of seconds, it output the number of jiffies. All right, so 50, okay, you just most, this is pretty simple. So we're supposed to create a function that looks like this. And then we type our code here. And so we're going to read in, we print out this way, okay. Okay, so we're going to read in the number of seconds. Enter number of seconds. And then we're going to compute jiffies equals seconds to jiffies, seconds. Print out the number of jiffies. Okay, well, let's see if we can, now, of course, we just take it and multiply it by 100, right? Well, you know that. Well, let's try to do it the same way we were doing it over here. Is this thing still here? We have it's a jiffy is 1/1000th of a second. So we have jiffy, 1 jiffy, J, 1 jiffy, F, Y, equals 1/100 seconds. And so if we divide, and we want to end up with jiffies at the end. So this is 1 second, 1/1000 seconds per jiffy. That's what this is. 1 seconds per 100 jiffies. Right, because 100 jiffies, I'll do it that way, equals 1 second. There we go. 100 jiffies equals 1 second. And so we want to input seconds and end up with jiffies. So we want, so it is, if we divide both sides by 1 second, divide this side by 1 second, and divide this side by 1 second, then this thing this cancels out. This cancels out, and this is equal to 1. So this is an equality. It equals 1. So yeah, that's what that is. So if we take 100 jiffies times 1 second and we multiply that by the number of seconds, times times some number x seconds, the seconds cancel, and we just end up with 100 jiffies times x equals x times 100 jiffies. Anyway, so that's easy. Jiffies equals user seconds input times 100. So 100, whatever is input from seconds, times 100 jiffies per second. Seconds cancel, and we end up with the total number of jiffies, and that's what we return. And so that should work. I'm not even going to bother to try to run it. All right, what's next? Leap years. Didn't we do this one already? We've done this one already in a previous chapter. Okay, so the year must be divisible by 4. The year is if it's a century, it has to be evenly divisible by 400. So the year mod 400 has got to equal 0. If the year mod 100 is equal to 0, then the so let me bring this back up. So so the first thing is the year must be, so we're inputting a year, and the year must be divisible by 4. So year mod 4 has got to equal 0. And if year mod 100 equals, if year mod 100 is equal to 0, then it's got to be divisible by 400. Then I guess I just do this. Then year mod 400 has got to equal 0. So really I can, okay, so I think that's enough to write code. So it can be something like, I got to write it in this format, huh? And the name of the function needs to be is leap year. Is leap year. And it's going to be I'm going to start out by saying is leap year equals false? We'll start out by saying it's false. And then I'm going to say if user year is mod 4 is equal to 0, then if user year mod 100 equals 0, let's see, I'm just going to try to do this the way I wrote it out before. If user year mod 400 equals 0, then is leap year equals true. Okay, so I got that part. Now, what happens if user year mod 4? Okay, so if user year mod 4, okay, else it's false. Else it already defaults to false, so I actually don't need to do it. It's already defaults to false, but I'm going to put it in anyway, just so it's more clear. Then ILY equals false. Okay, now, okay, so that takes care of the two cases when user mod 100 is equal to 0. So this takes care of that. Now, what about all the other cases when user year? What about all the other cases where user year is not equal user if how about when this is false? Okay, if this is false, that's the elif case. That's the else case. If this is false, remember this is still true. We're still in the case where user year mod 4 is equal to 0. We're still in the case where user year is divisible by 4. So if the user year is divisible by 4 and it's not divisible by 100, then we know it's just a plain old leap year. Is a leap year equals true. And then if the user year is not divisible by 4, then we know it's false. Else ILY equals false. Now, I think we've actually taken care of all of the ILY cases, because if it's true, we do this. If it's false, then it's false. Okay, so if this is true and this is true and this is true, then it is a leap year. Otherwise, if this is true and this is true and this is not true, then it's false. If this is true and this is not true, then it's simply divisible by 4 and it's true. All right, so I actually don't need this because I take care of all the cases. ILY will always be equal to something. If this is false, in other words, if it's not divisible by 4, we set it equal to ILY. Otherwise, in this case, if this is false, then we set it equal to something. If it's true, we take care of this. And if this is true, then either this is going to be true or not. If this is true, then ILY is true. Otherwise, ILY is false. And so I got to read in a leap year. So input the year, enter the year. And the integer, and then is a leap year equals whatever this is. So we call this function. This function is going to return true or false. And then we can print that out. If is a leap year, I think I just do that. Oh, it's no. Oh, if is a leap year. That's it. If is a leap year, then print the year is a leap year. Else print the year is not a leap year. I think this will work. Let's see. Enter the year. 1712 is not a leap. All right, what's wrong? Okay, let me just try. Let me just try 1713. 1713 is not a leap year. User year. If it's divisible by if it's equal to 0, then it's potentially a leap year. Otherwise, it's not a leap year. User year mod 4. User year. Read in the year. Call this function, and it sets this variable equal to that. If it's true, it does that. So 1712 must be divisible by 4. It is. So that means we're down here. And 1712 this is not the case. That's false. So we should return true. Oh, I never. I got to return ILY. Return ILY. It must have returned none, and none would not be true. None would default to false, probably. Okay, let's see if it works now. 1712. 1713. Yes. What else do we want to try? Oh, that's it. 2000. It's a leap year. 1900 is not a leap year. All right. Okay. It is 4:37, and it's getting kind of late here. And probably want to go see if we know who our president is yet. I don't know. Don't see it yet. The 100 cases of coronavirus cases today, and there's 150 something yesterday. We might go back into phase 1 or whatever it's called. Anyway, so are there any questions? Hearing none, this meeting is adjourned. See you on Tuesday. Thanks for watching.